1.2, fraction and integer operations. We have a nice, easy one again today. So you have all seen integers, I promise you. Let's go over that definition. Integers are the positive and negative counting numbers. So counting numbers, those are whole numbers. So for example, -3, -2, -1, 0, 1, 2, 3, so on and so forth in both directions. We call those integers. We're going to do our super basic 4 operations with these integers. We're going to throw in some negatives in there to confuse us. But basically, we're doing addition, subtraction, multiplication, division. So if you want a calculator for this, get one out. But can we do 1 plus -16? What does it mean when I do plus a negative? What is that the same as? I saw hands flicker like this and then get scared. What happened? What's the same thing as adding a negative number? James? Yeah, it's the same thing as just subtraction. So if I have 1 plus a -16, I might think in my head 1 minus 16, which gets me -15. Go away. Okay, so then if I look at letter B and it says -8 minus -13, what does it mean when I subtract a negative? Yeah, it's like adding. So if I have -8 minus -13, I'm going to change that to -8 plus 13. Okay, so if I have -8 plus 13, I go from -8 to 0, and then 0 to 5. That's how I add negatives in my head. Did I do that right? I think so. Any questions there? I think we got this. So then letter C, same thing. Adding a negative is the same thing as subtraction. So -11 minus 9 more. When I subtract from a negative number, I'm getting more negative, so the number looks bigger, but it's actually smaller. So if I have -11 minus 9, what's my answer? -20. Oh, no. Same thing over here, -12 plus 3. My number is going to look smaller, but it's actually bigger. What's my answer? -9. Great job, great job. Okay, now multiplication and division rules. For letter E, I have -2 times 3. Is this going to be a positive or a negative number? Negative. A negative times a positive is going to be negative, so this should be a -6. What about if I do -8 times -4? Is that going to be positive or negative? Positive. 2 of the same signs are going to be positive, so this is a positive 32. Is the rule the same for division? Yes, it's the same rule. So -63 divided by a -9 is going to be a positive or a negative? Positive 7. And then what about 40 divided by -1? That's going to be -40. Any questions on that? Okay, here's the rules. Subtracting a negative is the same thing as adding a positive. So if I have a negative and then another negative, that becomes plus. When multiplying or dividing numbers that have the same signs, so 2 positives or 2 negatives, my answer is always positive. When multiplying or dividing numbers with different signs, my sign will always be negative. And then I'm going to add in one here. Adding a negative is the same as subtracting. Any questions on this? I think we're pretty good at adding whole numbers and subtracting whole numbers. So let's flip over and let's make things a little bit trickier. I know. Fractions. Okay, we got to remember our fraction rules. Sometimes fractions are tricky. When we add or subtract fractions, the fractions must have what? Common denominators. Perfect.
Boom.
When we are adding or subtracting things with common denominators, so I'm going to give you an example. 5/8 plus 7/8, right? We are going to add the numerators or subtract the numerators, which means the tops. So this would be like 5 plus 7 is 12. But we leave the denominators, aka the bottoms, the same. So 12 over 8. Simplify if possible. Yeah. All right. So let's go through the examples. Letter A. Can we simplify this? What can we simplify it by? We can take out more than a 2. We can take out 4. So we can take a 4 out of both of these. So if I take a 4 out of both, I get 3 on the top, 4 on the bottom. That's 3/4. Good? Okay, letter B. Do I have common denominators? I do have common denominators, right? So I'm going to add the tops together. 5 plus 2 is 7. I'm going to leave the bottom the same, 3. Now, I can make this into a mixed number, or I can leave it as improper. I always leave my fractions as improper fractions as long as they are simplified. So is there anything that goes into 7 and 3? No. So that's simplified. If you wanted to go a step further and make it a mixed number, you can, but I never do. So you will see on the answer key, the mixed numbers I believe are there. If you wrote this as 2 1/3, that is fine, but 7/3 is perfectly good with me. Okay, letter C. I don't have common denominators, so what am I going to have to do? By?
3.
Yes, I want to take that left fraction and multiply the bottom by 3 because I want to make it 15. But remember, what I do to the bottom, I have to do to the top. So I'm also going to multiply that 8 by 3. So I got 24 over 15 plus 2 over 15. Add together the tops. Leave the bottoms the same. Can anything go into 26 and 15? Can we simplify that at all? I don't think so. I think that's done. Again, make it a mixed number if you want to, but I think that's more work than we have to do. Okay, we got letter D. Not as easy as the last one. What are we going to have to do here? Multiply the denominators by what? Yeah. So do you remember the word least common multiple? It's the smallest number that two numbers can multiply together to. So 4 and 3, their least common multiple is 12. So if I want to make 4 into a 12, I have to multiply it by 3. I have to do the same to the top. If I want to make 3 into 12, I have to multiply it by 4 and do the same for the top. So this new expression is going to be 15 over 12 minus 4 over 12, which makes 11 over 12. Any questions there? I'm not telling you rocket science, right? We've all seen this before. Okay, perfect. Multiplying and dividing fractions, I think, is arguably much easier than adding and subtracting fractions because what don't we care about anymore? We don't care about those common denominators anymore. We can just multiply and divide whatever we want to together. So, to multiply fractions, we multiply the numerators together, and we multiply the denominators together. which means we're multiplying all the tops all the way across. We're multiplying all the bottoms all the way across. Dividing gets a little bit tricky. Does anybody know what our rule is for dividing? Keep, change, reciprocal. I use keep, change, flip. Perfect use of the vocab there. We keep the first fraction the same, and we are going to multiply it by the reciprocal of the second fraction. Reciprocal just means flipped. So again, a cool way to kind of remember this, the way that I remember it at least, is keep the first one the same, change the sign in the middle, and flip the last fraction. Okay, let's practice multiplying and dividing. So with letter A, 1/5 times 2/7. No common denominators, but that doesn't bother me at all. I'm going to multiply the top two numbers together, 1 times 2. I'm going to multiply the bottom two numbers together. And then I'm going to double check that I can't simplify this anymore. Am I good here? Yeah, we're good. Same thing with B. I got 2 times 1 in the top. I got 3 times 4 in the bottom. Can I simplify this one? I think so. What does it simplify to? 1/6. Okay, here's the division part. Here's where we get a little tricky. Remember, we keep the first one the same. So 4/5 stays 4/5. I'm going to change that division sign to multiplication. And then 2/5, I'm going to flip it. I'm using its reciprocal. 5/2. And then multiply 20/10. What does that simplify to? Perfect. Any questions on that? Okay, somebody help me with the last one. Who's got it? Jaden.
2/9 times 6/5.
Yep.
Equals 12/5. But then you need to simplify it, divide it by 3, and then you get 4.
Yep, we can divide both of those by 3, and we're going to get 4/15, and we're good there. Any questions on that? That's it. That's all I got for you today. Easy enough?